Okay, we are going to talk about exponents today. Now, we are doing this because we're going to be working with polynomials and we will have to add and subtract polynomials, we'll have to multiply polynomials, so we're going to need to know some properties of exponents. So to do that, let's start with the first part of this, which is what is an exponent? So an exponent is really just shorthand notation for multiplication. So when we look at an exponent, there are two pieces. We have the base, all right, and then we have the actual exponent. Now, the exponent is telling us how many times to multiply the base. So if I have 3 to the 4th power, that really means I need to multiply 3 4 times. All right, so an exponent is allowing us to condense this string of multiplication to just a little bit tidier representation of extended multiplication. So all of our properties are going to extend from this fact. So if we look at some problems like this, all right, so if we know this problem, all right, this is really 5x's, 1, 2, 3, 4, 5. And then this is really another 12 being multiplied. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we really have this string of x's being multiplied together. Well, in essence, really what we have would be 17 x's multiplied together. We have 5 in the first group, 12 in the second group. So really we can write this using our properties of exponents as x to the 17th power. All right, in a very similar fashion, we have 4 7s multiplied in the first group, and then 16 7s in the second group, and then we're going to multiply those two groups together. So really what we're going to have is 4 7s here times another 16 7s here. So we're really multiplying 20 7s together like so. Now this works, all right, no matter how many terms we are multiplying, as long as, all right, all these terms have the same base, because that's telling us how many of that number to multiply. So we have 15 m's here, 5 m's here, 12 m's here. So in total we have 15 plus 5, which is 20, plus another 12, which is 32 m's being multiplied together. So in general, when we multiply two things with the same base, we add the exponents to get the total amount of items we are multiplying. So the first rule, all right, for our exponents, the product of powers property, is such. All right, a to the m times a to the n is going to equal to a to the m plus n. Now this will work for any string of multiplication, even if we mix, all right, different bases in. So I'm going to show you an example of this. All right, so notice we have this problem. All right, so we want to simplify this. So really what I want to know is how many a's are we multiplying? So we have 4 a's here and only 1 a here. So remember, this is a to the first power. So I'm really multiplying 5 a's. So I can just go ahead and write that as one term, a to the 5th power. And then I need to look at the next type of base, which are b's in this case. And I have 6 b's multiplied here times 12 b's here, which means I'm really multiplying 18 b's together. So we can apply the product of powers property to each base within a string of multiplication such as this, to where then the final answer would be a representation with one base, all right, per type of term. So one base A, one base B. All right, so here's what I'd like you to do. All right, here are two problems, and so what I'd like you to do is go ahead and pause the video, and I would like you to apply the property that we've just discussed to find an answer for these two problems. So, all right, so the answers you should have come up with are x to the 8th times y to the 14th times z to the 11th. For our second example, you should have come up with a to the 15th, b to the 9th, and c to the 5th power. All right, so let's try another type of problem that we will see with exponents, which involves a power to a power. All right, so when we look at this, we're really going to apply the same principle that we just talked about. Okay, this exponent tells us how many times we're multiplying the item within the parenthesis. So this is really a to the 5th times a to the 5th times a to the 5th times a to the 5th. So we can see that we really, once again, are using that same property that we just went over. All right, so this exponent tells us how many times to multiply this guy. Now, then we can reuse it. We have 5a's, another 5, another 5, another 5. So we really have a to the 20th power. Now, a shortcut to this is that we can just multiply these two powers together, because I have 4 sets of 5a's. So I would have 20a's total. So, for example, if we had x to the 6th power raised to the, third power, this would really be x to the 6th times x to the 6th times x to the 6th. So 6 plus 6 plus 6 would be x to the 18th power, or we'd have 3 sets of 6, which is a multiplication problem. So our next property, which is the power of a power property, which just says when we raise something to a power, we can really just multiply those two pieces. Now, once again, if we only have one base within the parentheses, we just apply this property once. If we have more than one type of base, as you will see in a couple of examples in just a moment, you will have to apply this to each individual base within the parentheses. So let's take a look at a couple of examples here. So the first problem here, we have 3 4's being multiplied. So once again, this says I have 4 groups of 3. So if I have 4 groups of 3, I really have 12 4's multiplied. Now, once again, if you wanted to, you could write this out, following our properties that we just discussed. 3 4's, 3 4's, 3 4's, 3 4's. Oh, okay, that is, I should have a times here, sorry. And that would be 4 to the 12th power. So remember, if you get confused here, you can always rewrite it and then use the same property that we've discussed. Okay, so now notice on the next problem, we have 2 different types of bases within our parentheses that's being raised to the 3rd power. So I have to apply this 3rd power to each individual piece. So notice this says I have 3 groups of 4a's. Well, if that's the case, that means I would be multiplying 12a's total. Then I come to my next base. Okay, this says I have 3 groups of 9b's. So once again, I would be multiplying 27b's. Now, if you wanted to, you could do a to the 4th, b to the 9th, times a to the 4th, b to the 9th, times a to the 4th, b to the 9th. So we could still use that property. Oh, a to 4, a4, a4, that would be 12a's. 9b's, 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 I'd be multiplying 27b's. So now if we take that and extend it here, notice we have lots of terms here. So you just have to go base by base. So I have 7 groups of 2 5's. So that means I really have 14 5's total. Then I go to base x. Then I have 7 groups of 2 x's, which means I would have 14 x's. Then I go to base 9. I have 7 groups of 9, which means I have 63 y's. Then I go to my base z. I have 7 groups of 6, which means I would have 42 z's total. So you just simply go through, and work those problems out, just like that. Now, what I'm going to do is work one problem with you, to show you how you can combine the two things together. So when we look at this problem, now we're going to do 2 pieces here. Okay, so the first is I have to do the power to a power property here and here. So when I look at this, remember that this is really -7 to the 1st power. So I have 3 -7's. So I'd have -7 to the 3rd power. Then I have 3 groups of 5c's. So that means I have c to the 15th power. Then I go to my next parenthesis. Once again, this is 8 to the 1st power. So I have 2 8's, so that would be 8 squared. Now notice the difference here. Since this is a positive number, I don't need parentheses. Versus here, if this is a negative number, you will want to put that in parentheses so that that negative, is included within your power here. Now I'm going to go back to this problem. Now I have 2 groups of 4 here. So now I know that I have c to the 8th power. Now I just do these individually. So -7 to the 3rd power is -343, and then I have c to the 15th, 8 squared is 64, and then c to the 8th. Now remember, this is all multiplication. So now this is 343 times 64. okay, which gives us a very large number, negative 21,952. And now I can see, okay, I have 15 c's here and 8 c's here, so I have c to the 23rd power. So this is a way that you can use all of the properties that we have discussed so far. Now, it is also acceptable that if you had wanted to, you may have left this in terms of power. So you could have written negative 7 to the 3rd power times h squared times c to the 23rd power. And that sometimes is a very acceptable answer if we're just trying to simplify depending on what you want. Multiple choice test, you probably will see it written like that, and so you just have to know how to multiply these out. All right, so now what I want you to do is go ahead and pause the video. I'm going to give you, well, let me go skip to the examples here. And so I want you to go ahead and pause the video, and I want you to attempt, all right, these two problems, all right, and see how you do with combining all of our work. Okay, let's look at the answers. All right, so notice what I did here. I just went ahead and left them in power form. So 8 to the 4th, 6 to the 4th times y to the 36. Now, if you went ahead and multiplied 8 to the 4th out and 6 to the 4th out and came up with one very large number here, perfectly acceptable, no problems at all. Okay, example 2 here. Notice once again, I just left it in terms of the power. Negative 2 to the 3rd times negative 3 to the 3rd, a to the 21st power, and then b to the 12th power, all right, for those. Okay, so we're going to talk about two more properties, all right, before we finish here. So now let's look at one more property here, all right, and this property, all right, involves division. Now, we're going to take a common sense approach to these, okay, and we're going to talk about a couple things here. So once again, we're going to go back to what does a exponent mean? So this would be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 x's. All right. Then I would have 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. So by the definition of an exponent, we know that there's really a string of 16 x's being multiplied in the numerator, divided by a string of 9 x's in the denominator being multiplied. Now, when we work through this, we're just going to take and divide. X divided by x is 1. X divided by x is 1. 1. 1. 1. 1. 1. 1. 1. So notice the first 9 x's in the numerator, all right, divide with the first 9 x's in the denominator, and those all equal to 1. So what's left? 1, 2, 3, 4, 5, 6, just 7, all right, x's in the numerator. And if we shorthand note that with our exponent, that's x to the 7th. Now, what is left in the denominator? All right, and that would actually be just 1, because all of these things divide to be 1, so it's really 1 over 1. All right, so x to the 7th over 1, or just x to the 7th power. Now, notice, the number of x's in the numerator was greater than the number of x's in the denominator. Therefore, the remaining amount was in the numerator. Now we have, all right, the opposite situation here. We have 1, 2, 3, 4, 5, 6, 7, 8 x's in the numerator. And we have 13, 5, 6, 7, 8, 9, 10, 11, 12, 13, all right, in the denominator. Now, once again, x divided by x is 1, 1, 1, 1, 1, 1, 1, and 1. So the first 8 exponents, or excuse me, the first 8 x's in the numerator divide with the first 8 x's in the denominator to give us 1. Well, notice, where are the remaining exponents, or excuse me, x's? They're in the denominator. And once again, if I write this as an exponent, that would be x to the 5th power. Now, once again, what's left in the numerator? Just 1. All right, because this is 1 divided by 1, so this is really like 1 over 1, like that. All right, so really all we need to do is, when we have division, is figure out, okay, where do we have more of the base? Numerator or denominator? And that's where the remaining amount will end up. All right, so now, as a shorthand way of remembering this, okay, if a is greater than b, so if, okay, the number in the numerator is greater than the denominator, my result will just be x to the a minus b. So in that prior example, 16 minus 9 was 7, so I ended up with x to the 7th. If the number of the base is greater in the denominator than the numerator, they're going to end up in the denominator. And once again, it's still going to be a minus b, so like in that prior example, 13 minus 8, which was 5, so I ended up with 1 over x to the 5th power. All right, so let's look at a few examples applying this. All right, So if we look at our first example here, all right, I know I'm starting with a fraction, so I'm going to go ahead and write this out as a fraction. Now, the first thing I do when I look at this is, which bases do I have? I have base x. Where do I have more base x? In the numerator. Okay, how many more do I have? 2. So I'm going to end up with x squared over 1. And this denominator is going to be 1 because those first 5 x's divided with those first 5 x's, which leave us 1. Now, when I look at the next problem, once again, okay, I have a base x and a base x. Where do I have more of my base x? Well, in the denominator. So that's where my result is going to end up. Now, how many more do I have? Okay, 15 minus 11 is 4. So I have 4 extra x's in the denominator. And then once again, that number in the numerator will be just 1. All right, so now going to the last one here. Okay, once again, I have base x over base x. Great. Where do I have more? In the denominator. How many more do I have? Well, 9 minus 6 is 3. And then once again, that would be 1 in the numerator. Now, once again, if you get confused, you can write them out. So 6x is in the numerator, 6x is in the denominator, or 9x is in the denominator, and then start doing division and find out how many you have left and where. And that will work out every time. Now, let's look at this with, all right, the context of a couple more problems that we have here. Okay, and we're going to incorporate some of our prior properties. Okay, so now, all right, let me go ahead and pull up my writing screen here. So notice we have to apply the power to a power property before we can do the division. So I have 4 groups of 3 x's, so that means I really am multiplying 12 x's in the numerator. I have 2 groups of 5 in the denominator, which means I'm really multiplying 10 x's. So notice once I do my power to a power property, then it becomes just like the prior problem. Okay, I have base x over base x. Where do I have more base x? In the numerator. How many more do I have? 2. So x squared over 1, or just x squared. Now, looking at the next example, I'm going to do my power to the power property. I have 3 groups of 5, so I have 15 a's in the numerator. I have 4 groups of 6 in the denominator, so I really have 24 a's in the denominator. All right, so now, where do I have more base a? I have more base a in the denominator, so that's where my result's going to be. How many more do I have? 24 minus 15, all right, which is 9. And then once again, my numerator will just be 1. All right, so you can see how we incorporate, all right, those things into those properties into the same type of problem. Okay, now I'm going to do one more just to show you, all right, that you really just proceed the same way if you have multiple bases, just like we discussed before. And then I'll let you do the last 2 on your own. Okay, so if I go to this problem, once again, I take care of all of the same bases first. So I'm looking at base x first. Okay, so I have 12 x's in the numerator, 5 in the denominator. All right, I have more in the numerator, so that's where my result is going to be, and I have 7 more. All right, then I'm going to move to base y. Okay, I have 11 in the numerator, 15 in the denominator. Okay, so I have more in the denominator, so that's where my result's going to be. All right, so then I have 4 more. So my final answer is x to the 7th over y to the 4th. Now, technically, there's a times 1 here and a times 1 here, because we would have written x to the 7th over 1 normally, and 1 over y to the 4th here. But since there is another component here, we know that when I multiply by 1, it's just going to be that component. So x to the 7th over y to the 4th would be your final answer. All right, so what I would like you to do right now is go ahead and pause the video and attempt these next 2 problems, all right, and see how you do. Good luck. Okay, let's see how you did on those last 2 problems. All right, so you can see the answer here to my problem that I did. Okay, so if you go through here, okay, we definitely have more base a in the denominator. We have 3 more, so a to the 3rd is in the denominator. Then I move to base b. Okay, I have more b's in the denominator, and there's 8 more, so it's b to the 8th. And then I have more c's in the numerator, and I have 6 more here. Okay, so here you had to do the power to a power property first. And then once you simplify, you have more x's and more y's in the denominator. So 24 and 31. And remember, if we have nothing left in the numerator, we put the 1 in because we have that 1 from the division of the x's divided by x's. And in this case, the y's divided by the y's. All right, so one more property to just discuss that may come up from time to time, and that is the 0 property. So what is something to the 0 power? All right, so for example, if I have 6 to the 0 power, what would that be? Now to develop this, I'm going to go through a couple of properties here. So if we say we have 6 squared, that's really 6 times 6, which is 36. So now if I want 6 to the first power, I really want to divide everything by 6. Okay, so then that's 6 to the first power. Notice those 6's cancel, which leaves me a 6, and then 36 divided by 6 is 6. All right, so now if I want the 0 power, I would divide by 6 again. So then this gives me 6 to the 0 power, which is 1, which is 1. So 6 to the 0 is 1. All right, because it's really a pattern of division and undoing that multiplication that we talked about. All right, so really if I show you one more example here, so 2 to the third is 2 times 2 times 2, which is 8. So if I divide this by 2, okay, you can see 8 divided by 2 is 4. Okay, that's gone, so I'm still left by 2, which is really 2 squared. Okay, then I can divide everything by 2 again. Just move the screen down a little bit here. So 4 divided by 2 is 2. 2 divided by 2 is 1. That leaves me 1, 2. And then so that means that this has to be 2 to the first power. And then if I divide everything by 2 again, you can see this is 1. This is 1. And then so this must be 2 to the 0 power. So if it comes up, all right, a to the 0, okay, is 1. So anything to the first power is 1. All right, so that wraps up our video on properties of exponents. All right, so please check in with me in class next time, and we will discuss your notes and the homework assignment for this video. Very nice.